Yeah, hello. So this is Christoph here. Today I want to show you a little demo how to test serverless workflows. The tools I'm using here is Kogito for the implementation of the serverless workflow, and for testing I'm using a framework called YAKS. I have a little sample here of a serverless workflow. It's a play to win um, example. So here we have an overview of the workflow itself. So we begin with a new entry event. Actually, this is a Knative event that triggers the workflow. And then we enter the check winner state. In this state, we call a first foreign service via HTTP to actually check if the user has won a prize. So it returns a result, true or false, this operation. Um, if we have that, we go into this has won switch state. So based on the response that we got from the foreign service, we will either end the workflow when the user has not won a prize, or when the result is true, then we go into the next step, which is called get employee details. And this state calls another foreign service to get some shipping details for the user. This is also a call over HTTP. And if we have this response, we create a price and we inject this price into a new event, which is the price one event, and this event will be sent to the Knative eventing. So this is the overall workflow that we want to test right now. And if we want to test such a thing, it's a good idea to also run the test inside of the Kubernetes environment, as the serverless workflow is also running on Kubernetes and is also connecting to Knative and other services. So with the framework YAKS, you can do this. So YAKS is a framework that brings the testing to the Kubernetes platform, and we will have a look how this works. Here again, we have this little implementation of the serverless workflow. I'm using a Kogito implementation, and this is the actual workflow source in JSON. So here we have all the states, and we have all the functions calling the foreign services for the isWinner operation and for the get employee details operation. We have the different states here. We have the switch state where we check on the result of the isWinner operation and so on. So I have this already running on a OpenShift. So here we see that the Kogito service is actually deployed as a Knative service. So actually it's scaled down to 0 right now, but as soon as we run some tests, this will automatically scale up. And we have a default Knative broker in here for the events. And we have a sync binding, which actually tells the service where to send the price one events. And if we want to test this, or if we want to write a test in YAKS framework, what you have to do is to write such a feature file. So this is using behavior-driven development concepts. Actually, behind the scenes, this is running in Cucumber, which is a quite popular Java implementation for behavior-driven development. And on top of that, YAKS is providing some out-of-the-box steps that you can use to interact with Knative, interact with other services on Kubernetes and OpenShift like CamelK or HTTP and so on. So let's have a look into this feature file. So we create some supporting services. As I said, the workflow will actually call two other services via HTTP. So we create some supporting services here, actually also the Knative broker. We create the Knative broker and we check that the broker is running. Then we create an HTTP server as part of the test runtime. This HTTP server is called Kogito Test, and this is where the Kogito workflow or the serverless workflow will send its outgoing calls to. So we can have a look into the application properties here. we can see that there is a base path for the score service and for the employee service, and this is pointing to the Kogito test server. So here we start this HTTP server and we also expose this service as a Kubernetes service. So when the serverless workflow is running in OpenShift, it can actually then send its calls to the Kogito test service, and the test is able to receive those calls. At the very end, the serverless workflow is supposed to create a price event. So we also create a event consumer service for that in Knative. We call it a price service, and we create a Knative trigger for that. And we filter on attributes of type prices. So at the very end, when there's an event, we should also be able to receive this in the test and to verify its content. So now that we have these supporting services ready, we can just start our scenario for the user wins a prize. We have a name for the user, and the first thing that we have to do is to create a new participant event. So this is a Knative event that uses this payload. We have this username and we reference the variable that we have created in here. And we send this Knative event to the default broker by specifying the cloud events specification in here. So this is where the workflow should be triggered, because the workflow just listens for these new participant events on the Knative broker. And then the next step would be that we receive a score operation, meaning the is winner operation. And here we are using the HTTP service that we have created before. So the Kogito test service is able to receive a post request on /scores, and we actually give the response body and say that the user actually won a prize. So the result here is statically returning true. So every time that we run this test, the user actually wins a prize, and we specify some response headers and send the response back to the serverless workflow. So as we have returned this result true, and this is a very, very important concept, so we are in full control of the responses that are sent to the serverless workflow, so we actually can trigger the different switch states as we want to do in our test scenario. So in this scenario, we want to actually win a prize or return that the user has won a prize, so we return this true, and then we can actually go to the next step and verify the get employee details service. So again, we are using this Kogito test server, and we receive a get request on /employee, and we reference the name variable. And we also prepare an HTTP response with some shipping details for this test user. Again, we send this back to the serverless workflow, and the serverless workflow will then create this price event on Knative. And this is our next step. So we receive actually the Knative service on this price service, which is triggered by the trigger that we have created up front. And then we can verify that the event data is as expected. So we have actually the first name, last name, and address. We have this price that the user has won, and we can actually receive this Knative event as a last step. So this completes the whole process. So once again, it's very important that we are able to control the flow. So the workflow has some different states, and we actually trigger the states, we verify the different states, and we are able to completely test the whole workflow. So this is the feature file, and in YAKS you can use a CLI, which is called YAKS, to actually run this feature. And if we just run this feature, I'm connected to the OpenShift that we have seen. So we should see a new test here popping up, which is controlled by the YAKS operator. And this test will then create this new participant event. And once this is created, we should see the serverless workflow pod spinning up. Yes, we see this. It's starting. And actually now the workflow is triggered and everything that we have seen before should be executed. And we also see that the test is already green. So going back to the output, yeah, we see that there's a lot of success in here and a lot of green steps, which is great. So everything that we have specified in our test now is verified, and we have seen that the serverless workflow really sent out this price event at the very end. So another thing I want to show you is that OpenAPI specification, or at least maybe let's have a failing test just for the record. So in this very last step, I'm just wanting to let this fail. So I'm expecting a result false, which obviously should be a result true. So, and if I rerun this test, I should be provided with a failing test because the resulting event is having a false instead of a true. So let's quickly respin the test and see if this is failing as expected. So as I said before, I have a YAKS operator also installed, and if I'm creating this test as a custom resource, then the YAKS operator will actually provide the runtime and run the test inside of the Kubernetes environment. So this was failing as expected, and we also see that the value for the result is not as expected. So it was expected false, and it was true. So of course this was true. And now I want to show you some more features for YAKS, and this is especially also great in the area of serverless workflow because we are dealing with OpenAPI specifications a lot. So the calls to the foreign services are OpenAPI specifications. So let me open this. Here is the OpenAPI specification for the isWinner operation. And here is the OpenAPI specification of the getEmployeeDetails operation. And in our test, we can actually leverage this information here and make use of this. So let me have a difference here for you, so a small diff so that you can see. Actually, the test is the same. It's triggering a user that wins a prize, but right now I'm not using the pure HTTP protocol to receive events and to send responses back. I'm using the OpenAPI specification. So instead of really receiving this HTTP stuff, I'm loading the OpenAPI specification for the isWinner operation. And actually what I'm able to do is to say I verify the operation isWinner. And what YAKS is doing, it reads the specification and it reads the operation isWinner and actually generates all the verification. So it will verify that this is a post request on /scores resource. It will verify the content header and so on. And it will also, and this is also quite nice, it will generate a proper response. So if I say then send operation response 200, we will go into the specification. Here we have the isWinner operation and we have a response definition for 200 OK. And actually what YAKS is doing is generating a proper response based on these rules that we have in here. So the score result is having this results property and it's of type Boolean and everything is generated in this form. So if we say send operation response 200, it will actually generate a proper response. So I override the result here to true because I always want in this scenario that the user wins a prize. If I don't do this, then it is a random value, false and true, and I get a non-deterministic output. So also with the second call here, the get employee details, we can load the specification and we verify that the operation get employee details is called, and we send the operation response 200. And this again generates a proper response that we had in here before. And this will be a JSON with first name, last name, and so on. But now the values will be random strings. And this is why in the very end, I'm not able to actually have a string equals here for the first name. I just use a so-called validation matcher, just saying that the first name is a not empty string. So let me just run this quickly for you, so that you see that it's quite the same result. And here we can see some failing tests. This was the failing test before, and now we have a new test spinning up. Our service is auto-scaled to 0. It will shortly have a pod running, and hopefully then the OpenAPI specifications will also succeed. Yeah, so we have a green test. This is also successful. And a last thing that I want to show you is why are we using this OpenAPI specification. So let's assume that we have a change in the employee service. So this is a new version. And we just, in this get employee details, we have a new parameter, which is called like a token, and it lives in the query section. It is required. And if we have this change in here, then the test will automatically grab this change and will align with this new specification. So right now, if I rerun the test, I'm expecting a failing test because our service in here is not updated yet. So it's using the old specification, and we are using a new specification in this test. So I expect this to fail. Let's see. Yeah, we have a failing test. And let's have a look into the validation message here. We see that there is a missing token, a missing query parameter token. So actually, this is always using the latest or the actual version of the OpenAPI specification, and we actually get notified when there is something wrong in our service, because our service was just missing the query parameter because we actually didn't load or update our service yet. So so much for OpenAPI specification. What I also wanted to show you, now that I have a failing test, we are provided with a so-called dump of the namespace, so which is quite great, because then we can just review what actually has happened. So if I scroll up a bit, so the dump is holding all information that actually is causing the failing test. So we have the test custom resource in here. If we scroll down a bit, we see actually the whole test sources that we were using in here, and we have the operator logs from the YAKS operator. So here are the operator logs in this dump, and if we scroll down a bit, we should also see the logs of the test pod and a lot of other information like config maps and jobs and so on. So actually here we see the stack trace of our failure that we had. And what is also great is that we also can see the serverless implementation. So the Kogito pod that was running, we can also have a look into the pod logs and see why there was something failing. So we can see here the results of the different calls, and at the very end we can see that there was an IO exception because the Kogito test was not sending a response back because of the failing tests. So this completes pretty much what I wanted to show you. I think this is a pretty cool combination of Kogito and YAKS, and you can do a lot of cool testing with that. So thanks for watching.